Physics is the fundamental science that explains the behavior of everything around us. From the tiniest particles to the vastness of the universe, physics shapes everything we see, feel, and experience. It is the science that governs how objects move, how energy works, and even how forces interact with matter. Let's break it down. We will start with the most essential building blocks. The building blocks of matter, atoms, and particles. Everything in the universe is made of atoms. These are the basic units of matter, composed of protons, neutrons, and electrons. Protons and neutrons are packed into the central of the atom, called the nucleus, while electron orbits around the nucleus. The behavior of these particles determine the properties of everything you see, from the air you breathe to the stars in the sky. These particles interact through fundamental forces, and the study of these interactions is what physics is all about. There are 4 fundamental forces that govern everything in the universe. Number 1, gravitational force. This is the force that attracts objects towards one another. It's what keeps planets in orbit around the sun and makes objects fall to the ground. Gravity is a weak force but acts over vast distances, which is why it governs the motion of planets, stars, and galaxies. Number 2, electromagnetic force. This force acts between electrically charged particles. It's responsible for all electric and magnetic interactions. This includes everything from light and radio waves to electricity and magnetism. Electromagnetic force is much stronger than gravity. It acts over much shorter distances. Number 3, strong nuclear force. This is the force that holds the nucleus of an atom together. It binds protons and neutrons tightly, overcoming their repulsive electromagnetic forces because they are all positively charged. Without a strong force, atomic nuclei would fly apart. Number 4, weak nuclear force. This force is responsible for radioactive decay and plays a key role in nuclear reactions in those in the sun. It's weaker than the strong nuclear force and electromagnetic force, but it's crucial for some fundamental processes in the universe. Motions and Newton's laws. Newton's 3 laws of motion are essential in understanding how objects move. Number 1. First law or inertia. An object at rest stays at rest, and an object in motion stays in motion at a constant velocity unless acted upon by external force. This means that things won't change their state of motion unless something pushes or pulls them. Number 2, second law, that is force and acceleration. The force acting on an object is equal to its mass times its acceleration. F equals ma. This law tells us how object responds when forces are applied to them. A heavier object needs more force to accelerate at the same rate as lighter objects. Number 3, the third law, action and reaction. For every action, there is an equal and opposite reaction. This means that if you push on a wall, the wall pushes back on you with equal force. This law explains everything from walking to launching rockets. Now, let's come to energy, the ability to do work. Energy is the capacity to do work. It exists in many forms, including kinetic energy, or energy of motion, potential energy, that is energy stored due to position, and thermal energy, energy from heat. The law of conservation of energy states that energy can't be created or destroyed, only transferred or transformed from one form to another. For example, when you lift an object, you give it potential energy. When you release it, that potential energy is converted into kinetic energy as the object falls. Waves and light. Waves are disturbances that transfer energy. There are 2 main types of waves. Number 1, mechanical waves. These require a medium like air or water to travel through. Sound is an example of a mechanical wave. When you speak, you create vibrations in the air, which travel as sound waves to the listener. Number 2, electromagnetic waves. These do not require a medium and can travel through a vacuum or space. Light is an electromagnetic wave. These waves can have different wavelengths, and the entire spectrum includes everything from radio waves to gamma rays. The visible spectrum, the light we can see is just a tiny part of this spectrum. Light behaves both as a wave and a particle. This is called wave-particle duality. In some situations, light behaves like a wave, as in interference and diffraction, and in others it behaves like a stream of particles called protons. The theory of relativity, space and time. Einstein's theory of relativity revolutionized our understanding of space, time and gravity. There are two parts to this theory. Number one, special relativity. This theory shows that laws of physics are the same for all observers, regardless of their motion. It all explains that speed of light is constant and that time slows down and distances contract as an object approaches the speed of light. This leads to phenomena like time dilation, where a clock moving at high speed ticks slower than one at rest. Number two, general relativity. This extends special relativity include gravity, which Einstein described not as a force but as a curvature of space-time caused by mass. This means that large objects like planets and stars warp the fabric of space-time, and smaller objects move along these curves, which are perceived as gravitational attraction. Quantum mechanics, the world of the very small. At the smaller scales, the rules of classical physics break down and we enter the realm of quantum mechanics. This field explains the behavior of particles like electrons and protons. One of the fundamental principles of quantum mechanics is quantization. Energy comes in discrete packets called quanta. Another key concept is uncertainty. The Heisenberg uncertainty principle states that we can't know both the position and velocity of particle with absolute precision. The more accurately we know one, the less accurately we can know the other. Quantum mechanics also introduces the idea of superposition, where particles can exist in multiple states at once, only collapsing into one state when observed. Thermodynamics, heat and energy transfer. Thermodynamics is the study of heat and energy flow. There are four fundamental laws. Number one, zeroth law. If two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. This leads to the concept of temperature. 2. First law. This is the law of energy conservation. Energy can neither be created nor destroyed, only transferred or converted. Third, second law. This law states that the total entropy or disorder of a closed system always increases over time. This explains why natural processes like mixing hot and cold substances move toward equilibrium. 4. Third law. As the temperature of a system approaches absolute zero, the entropy approaches a minimum value. The standard model of particle physics. The standard model is a framework that explains how particles and forces interact. It classifies all known fundamental particles into categories: quarks, which make up protons and neutrons; leptons, such as electrons; and bosons, which mediate forces like the photon for electromagnetic force. The Higgs boson, discovered in 2012, is also part of this model. It gives particles mass through the Higgs field, explaining why some particles have mass and others don't. Unsolved mysteries, dark matter, and dark energy. Despite our understanding of most of the physical world, there are still some mysteries. For example, about 85% of the universe's mass is made up of dark matter, which we can't detect directly because it doesn't emit light or interact with electromagnetic forces. Similarly, dark energy is a mysterious force driving the accelerated expansion of the universe. In conclusion, physics explains everything from the motions of galaxies to the tiny particles in your body. It's a science that connects all things, providing the foundation for understanding how the universe works, from the simplest to the most complex phenomena. While there is still much to explore and discover, what we do know is that physics governs everything in existence, shaping the reality we experience every day.